Hey everyone, kind of following up on what we did yesterday with reviewing quadratic factoring. We're going to work with the Pythagorean theorem today. I know we worked on it before. We've already had a test on it. Everybody did fantastic on that test, but we want to kind of make problems a little more difficult as we go through this unit with the trigonometry part of it. It's going to help you see how everything ties together with the more difficult problems and similarity and stuff. But I want to get through it. And then tomorrow we're going to work on special right triangles, again, to kind of see how they all tie into what we're working on as well. So let's get going. Pythagorean theorem, we remember. We know the formula. A squared plus b squared equals c squared. What it is in words is that in a right triangle, the sum of the squares of the lengths of the legs of the triangle are equal to the square of the hypotenuse. Remember, the hypotenuse is always the c value. It's always the side opposite the right angle when you draw out your picture of the triangle, or if you're given a picture of the triangle, it's always the side opposite. When we start trying to classify triangles, the hypotenuse technically is still in existence in a scaling triangle where all the sides are different sizes. It's the longest side. The hypotenuse can always be considered the longest side of a triangle. Most triangles will have a long side unless it's isosceles or equilateral. Then it won't have a longer side. It'll have two long sides or all the sides the same length. So the hypotenuse is always going to be the longest side with three different numbers in your stuff. Like I say, we're going to be able to classify triangles too as well, so we're going to kind of move on. Classifying the triangles, these are the rules. We know if we're given three numbers, which is what you're going to be given, you'll be given three numbers. Trying to classify, it's a triangle. You'll know they're a triangle, but then you're trying to classify, is it a right triangle, a acute triangle, or an obtuse triangle? You plug your a squared, your b squared, and your c squared in. C squared always being the biggest number that you're looking at. And find out, is it a squared plus b squared is greater than c squared, that's less than c squared, or it equals c squared, and classify the triangles accordingly. So I want you to work on next. There are 9 problems. Take as much time as you need to figure them out, solve them, enter your answers in the Ed puzzle, and then we'll move on. So take your time, but make sure you get them done. Okay, here are all the answers, all of them all at once. I didn't realize as I was doing it until I kind of finished and went through myself that I didn't actually put an acute triangle on there. So they were all either right or obtuse. But you should, the process is the recognition of knowing what you're working with. What I want to point out on number 5 to kind of tie into what we're going to talk about next is I kind of showed it's like 3 times 3, 3 times 4, 3 times 5 as the numbers. So everything was multiplied by 3 from our triangle in problem 1. So what I was working with there and showing you was that special type of 3, 4, 5 triangle, which can be multiplied up by different multiples to get different side lengths, but it's always going to be a right triangle. What those are is Pythagorean triples. And a Pythagorean triple is a set of 3 numbers that form a triangle that satisfy the a squared plus b squared equals c squared, but the numbers are whole numbers. They're not fractions. They're not decimals. They are whole numbers. So it's 1, 2, 3. It's those numbers, the numbers we count with. So that's what you're going to kind of try to recognize as we're working through this. The next sheet I have here is a list of what we call primitives. They're calling them primitive, and I'll explain that in a minute. But they're the primitive common Pythagorean triples up to the point where c is less than or equal to 100. There's no Pythagorean triple where c equals 100 other than, actually that's not true, because the c value could be 100 if I'm looking at a what am I looking at? A 60, 80, 100 right triangle. That would be c equal 100, which we'll talk about in a minute. So the primitive ones they do not share a common factor. All the numbers, the a, the b, and the c, are all either a prime number, or they don't have a common factor. Two of them may have a common factor, but all three of them will not. And I'm trying to like scan them quickly and see if there are any that I can pick out right away. So if we kind of go down and look, and the almost last one here, the 36, 88, 85 triangle, which actually looks like it's in the wrong order. So we're going to forget that one because that one shouldn't be on there. I'm sorry about that. We do not want to recognize that as a Pythagorean triple. So the three above it, the 22, 56, 65 one. The 22 and the 56 both have a common factor. They can both be divided by 2. The 65 can't. So that's what I say is like they could have, 2 of them could have a common factor, but all 3 do not. If all 3 of them had a common factor, what we're looking at there is the workup of what I did on that last problem. So let's say I take a 3, 4, 5 triangle and I multiply everything by 6, then I end up with an 18, 24, 30 right triangle, but it's not a primitive one because they all have a common factor and it's built off of the 3, 4, 5 triangle. You can do that on any one of these triangles. I could multiply everything here by 6 and I'd have whatever that worked out to be. I could multiply all these ones by 10 and I'd have 130, 840, 850 triangle. You're able to do that. What you should try to recognize is in math and on tests as we're working on it, the SAT exams when you start taking those, the MCAS next year, you want to be able to recognize. First, you want to memorize these 3. You want to know that those are Pythagorean triples. Then you want to be able to recognize multiples of those 3 numbers. I know the third one's kind of hard to do. They're never going to give you really crazy ones, but you always want to kind of see what I always do when I was taking the test. If I was looking at a Pythagorean theorem question, trying to find the missing side, I'd always take the 2 sides they gave me and kind of divide them by the same number. If I can and they come out to be one of these, then I just multiply the third one of the triple by whatever number I multiplied by, and I get my answer rather than going through the Pythagorean theorem to solve and square root and all that. So hopefully that makes sense. Went a little bit longer there than I wanted to, but hopefully that makes sense. And again, I apologize for that one there that doesn't appear to work. What we're working on in this unit now, though, with the Pythagorean theorem is word problems. I want to incorporate some word problems. We got some in this sheet to work on yourself as we go through the notes, but then the homework is a bunch of word problems. It's 4. And then I'm going to pass out another sheet to the kids in class, but you'll be doing it on Classroom and plugging your answers into a Google form to do some more stuff that are word problems on that. So take a few minutes and go through these problems, enter your answers in the Edpuzzle, and then come back and look at the answers. Okay, so here we go. Here are the answers. Like I say in geometry, draw a picture. I drew a picture for both of them. My first one, I drew my triangle. I labeled my sides. I made my hypotenuse 28 because I know it was the longest side. Plugged everything in the Pythagorean theorem. I found out that a squared plus b squared ended up being 841, which was greater than, this should be 784. So my triangle is not a right triangle because a squared plus b squared was greater than c squared, which makes it an acute triangle. So that would be your answer for the first one. The second one, I drew my picture. I drew a nice little flagpole there, labeled my distances with what I did. The black line's the tether supporting the flagpole from the ground. I plugged in my heights, my distances, plugged everything into the Pythagorean theorem, found out that b equaled 30. Perfectly fine. I went the long way, plugged everything into the Pythagorean theorem. If you were able to recognize that one had a 4, one had a 5, I'm probably dealing with a 3, 4, 5 triangle. I've multiplied both 4 and 5 by 10, so yeah, I can say I am. I multiply the 3 by 10, I get my 30. I don't have to use the actual long distance math to get that. Squaring stuff, square root and stuff, doing it a lot faster. Does that make sense what I did there? Why we did that? Okay. Next one. Again, take a minute, work through the problem. find out how far apart the airports are, and then come back and look at the answer. Again, I drew another picture. Right triangle, traveled 60 miles east, which is to the right, went up 25 miles or north, so it formed a right angle there at that turn. The plane obviously didn't fly that way. It says it did, but it's kind of the way planes fly. They don't go that way. So I was looking for C, which was the hypotenuse. Plug stuff into the Pythagorean theorem. 25 squared plus 60 squared is going to equal my C squared. Go now, find out that, hey, C equaled 65. So the airports are 65 miles apart. I'm going to be honest on this one. It happens to me sometimes. I didn't recognize that if I divided 25 by 5, I'd end up with a 5. If I divide this by 5, I end up with a 12. If I go back and look at my Pythagorean triple sheet, the second one is a 5, 12, 13 triangle. So I could have then just multiplied 3. That would have made this side 13 for the 5, 12, 13 triangle. So I could have just done 13 times 5 and gotten 65 a lot faster than doing out the math. Hopefully you recognize that and caught that. I did not. I apologize. I mean, it happens. You still have ways, different ways to get the answer in math is okay. All right, the next one. I know this is something you haven't seen before. It's something that you did, concepts of it you did last year in algebra at some point. I want you to take a few minutes and try to solve and find out what x is. And then I want you to find the perimeter and the area of the triangle. Okay. Where to start? What we're looking to do, again, we want our formula, again, is a squared plus b squared equals c squared. So I'm going to just label my sides. I'm going to call this side A, this side B, this side C. Now I got to think, what I'm squaring a squared, I'm squaring this whole thing. This is what I'm squaring. So it's going to be x minus 1 squared, x plus 6 squared, x plus 7 squared. So I'm going to introduce the quadratic functions that we discussed yesterday to try to come down and solve for our x value. It's not going to be one of those simple ones where x squared plus 9 squared equals 100 squared. It's not one of those ones that you have to go and figure out the math. A little more algebra involved, but it's stuff I'm pretty sure you can do, especially if you understood yesterday's quadratic stuff. So I'm going to switch the slides and show you the answer. I kind of all color-coded it, try to make it easier for you to figure out. Just want to highlight it down here for a minute to show you what I did so you can see what I did here. These are the work I did to square the sides. So when I took my answers, I kind of plugged them up into the formula and then kind of solved. So when I squared A, I ended up with x squared minus 2x plus 1. That's the red number you see in my formula here. I squared b squared, x plus 6 times x plus 6. We know to FOIL it, or the box method if you saw that before. If you have questions, let me know and I can show you ways to do that. I ended up with x squared plus 12x plus 36. That's my number here. I squared the hypotenuse, x plus 7. When I did that, I got x squared plus 14x plus 49. So I have my squared equations done. Now I have to solve for x. And we remember back with quadratic formulas and functions, I want to set everything equal to 0. So I want to get everything on one side of the equal sign, set it equal to 0. So what I'm going to do is I'm just going to subtract everything that's on the right side of the equal sign. I'm going to subtract that from what's there. So it's basically everything on the right goes away, it becomes 0. I subtract my like terms. I end up with x squared minus 4x minus 12 equals 0. Now we're just back in yesterday's lesson where I factor that term down and I got x minus 6 times x plus 2. I needed factors that multiplied to negative 12 but added the -4. So I needed the -6. I needed the 6 to be the bigger factor. Went through and solved it. I know it's already crossed out. We'll talk about that in a minute. I went through and I solved it, and I got 2 possible answers for x. I got x equaled 6 or x equaled -2. So here's the thing with geometry problems like this that we always kind of have to watch out for and make sure we're understanding. Just because my x is negative doesn't mean it's not a good answer. That's not why I crossed it out. I crossed it out because now I have to plug this answer, the -2, back into my equation to see if it makes sense. So if I do -2 plus 7, that makes sense. That's 5. That works. If I do -2 here for x plus 6, and it was -2 plus 6, that works. That's a 4. So now you can be thinking right away, with 3, 4, 5 triangle. The third side is going to be 3. Well, the third side is 3. The problem with it is when I plug in the -2, I get -2 minus 1. This gives me -3. You can't have a negative side of a shape. It just doesn't work. That's why the -2 doesn't work for this problem. So that's why I kind of put that note there. So our answer is for x is x equaled 6. So now I plug 6 back into all my stuff. If I plug 6 in here, I get 5. If I plug 6 in here, I get 12. If I plug 6 in here, I get 13. So when I kind of add everything up and find my perimeter was 30. So you should have found a perimeter of 30. And then my area, again, would have been 30. Because it's 1/2 the base times the height. My base is 12. Divide that by 2, I get 6. 6 times 5 is 30. Does that make sense? Does everybody see that? I know it's a little bit more complicated problem. It's working with some algebra concepts that you had last year. You may not have quite remembered. We're foiling numbers. Like I say, I always say it, you guys are honors math students, so it's stuff that you should remember how to do. All right, let's move on to the last problem of the presentation. I'm sorry, the triangle's blurry. It's the best I could do where I got the picture from. We want to try to find x. X is here. It's part of a small triangle. It's the hypotenuse of this small triangle here. Kind of draw it in blue. A little bit sharper blue. I'm trying to find that. The problem is I don't have one of the sides, one of the legs. So I got to solve the legs, kind of look at it and say, well, how am I going to do this? Where am I going to get all these numbers from? What I did is I kind of went through and I labeled the numbers I'm going to find first. I'm going to find this value first. Then I went out and I found, I believe it was this value here second. Then that gave me the big long hypotenuse here third. Then this little short one fourth. And then I was able to find the 5th one. Yeah, that's how I did it. So here's all the work. I've numbered it. I put the color where I found the stuff in and read in different colors again. And then I've shown all my work. So I found the tall hypotenuse first. So the tall leg in this triangle here. Went through and solved. I rounded to 8.85. So I had my legs were 7.5 and 11.6. Then I went over to find this side over here. Did I do that right? Yeah, I could do that. Sorry, that's what I did. So I could find this side here, the second side, because I had my hypotenuse and I had a leg. So I did 2.7 squared plus b squared equal 13 squared. Went through, got all that. I found that that second leg there was 12.72. Then I needed the big long leg. I'm going to do this in as a kind of black highlighter line. I know it's going to look kind of gross. So I had to do this triangle then, the big dark long black one. So I added 7.5 plus 15. I got 22.5 there that I had to square. My leg was 11.6. I was finding the other leg as B. I went through that and I found out that that was 19.28. So now I had this whole length here was 19.28. I can extract out what I found in number 2 from that. So I got that this little short piece, the green piece, the fourth piece, was this 6.56. Then I was able to find my x value because now I had the two legs of that little small right triangle. 2.7 squared plus 6.56 squared equaled x squared. X squared was 50.3236. So then my x value became 7.09. Hope that makes sense. That was a hard problem. It's kind of tying in everything we've learned as we went through this. So that's where we are, the end of the presentation. Like I said, you're going to have 4 problems for homework. It's out of the textbook. There's another thing out on Google Classroom I want you to work on. It's a sheet of some problems. Make sure you get that. Upload the problems, or I might even have you just kind of put them into a Google form thing so the answers are there. And I will talk to everyone later.